Hey guys. Oh, Taylor. You can pop in and out. Naomi Shelby, good to see you. Black screen is like the kiss of death. So I enjoy seeing faces. I understand when people don't want to, but it means a lot. All right, I'm gonna just take quick attendance. We'll wait for some more people to filter in. Hey, Mike. We're almost there. Does anybody know Liam? Okay. All right. Let's wait 2 more minutes. How is everybody doing? Okay?
Yeah, pretty much.
Yeah, that's good. Things are ramping up, but not yet totally ramped.
Exactly.
Yeah, this is kind of the not so panicky phase. Is anybody struggling or needing some tips with the rough draft intro methods? Anything that wasn't clear in my email? I know it's not due till like midnight, so you guys still have time, but if you have any questions now might be an okay time to chat.
How much information like are we really supposed to be putting into like each paragraph? Because I was looking at one of the examples you attached in the Moodle site, and like they didn't have like a ton, I guess, in like each little like sub paragraph, and obviously it's not structured the same way.
Right.
But I just don't want to like end up writing too much in each one because I have like 2 paragraphs and it's like half a page. Or like like a full page, so I feel like
yeah. And Taylor can chime in as well, but I would think that if you could get 3 solid examples of biotic factors influencing and 3 solid examples of abiotic influencing, so from journal articles, if you could paraphrase a sentence or 2 and internally cite that, you know, author, comma, year at the end of that, you'll have a lead-in topic sentence. So usually, and I don't know if I mentioned this because we were outside, if you guys read an article, if you read the first sentence of every single paragraph, you kind of have a sense of what the article is about. And that the reason is they call those like lead-in topic sentences. So if you can have a broad kind of like, this is a general statement and it's gonna kind of describe what's gonna be in the rest of my paragraph. Like for example, on the biotic paragraph in the intro, you would say something like biotic factors are known to influence foraging choices. And then below that, you are bringing in examples paraphrased from those articles. But if you had, you know, one representing, you know, how competition could affect, one how predation could affect, maybe one how scavenging could affect, and then in the other one for the abiotics, you bring in something like temperature changing how animals feed, or deep snow changing how animals feed. You know, 1 or 2 of those examples I just gave would work. I would say, Taylor, would you say like you want to shoot for maybe a page and a half for your introduction?
Yeah.
Yeah, and your methods, you know, maybe a page, maybe 3/4 of a page on the methods. And that's once you've like really flushed out the data analysis, which right now you guys you're going to embark on it, but you might not have as much insight. So when you submit this one, that may just be a sentence or 2, you know, we're doing chi-square, we're going to do ANOVA to look at calories per chip, calories per forager. We're going to make these 2 graphs, but it's not going to be as robust as it would be when you submit it. Does that make sense? Okay. Any other questions on that?
Sorry. Yes, I have a question because I like didn't have any examples in my rough draft because I just struggled to find some.
Okay.
So is that gonna like dock a lot of points from it?
Well, the rubric has associated points, but the whole assignment rough draft of these 2 sections is only 10 points total. So it's not high stakes. What I would suggest to you though, Shelby, would be to maybe take another day with it if you have the time, and just pull in a couple and you can send it to me, or resubmit it if that's going to work. On the Moodle page, and I'll show you guys that in a sec, there are some example articles that will get you started. So each one of those should be something you could add into your paper. So if you just read through the abstract and kind of skimmed through their take-home messages, each one should be able to give you a sentence that you paraphrase and can internally cite. That'll help get you to where you need to be. If you'll notice, like at the end of our lab manual handout for this section, there's the entire rubric for the whole report. And at the very bottom, it says, basically it's the check mark for literature cited. You need, I think, a maximum of 3 of those articles. So ideally I want you to have more because I want you to get into, you know, the idea that research papers should be kind of robust, but at minimum you need to have 3. Okay. All right. Any other questions with the writing portion? Again, it's a draft. You're going to get a lot of comments back from me. You'll have tons of opportunity to revise, and when you revise, you're revising for big points, not the you know, small points that this assignment's associated with. Okay. And Taylor is on our call right now, and Taylor she's very seasoned in the science writing. So, you know, if I am not available, or if you want to touch base with Taylor on anything, you could shoot her a message too. Okay. All right. So I want to get us started, if that's okay. I don't think we're going to take the entire time. I'm going to do a screen share with you guys. Hold on one sec. I'm not in my home computer office where I have like 2 screens and all of this is worked out. I'm working off the one here, so just trying to make sure I can share with you guys all the things, not just some of the things. Okay, are you guys seeing the Zoom meeting and then a bunch of tabs at the top?
Yeah.
Okay, perfect. All right. Are you now seeing a data set?
Yep.
Okay.
Yep.
All right, so I'm going to switch us back to our Moodle site and make sure that you guys are comfortable with the content of our section on optimal foraging. And feel free to unmute and check in if you have any questions, okay? So as with all of our little subsections, I start off with a little blurb, and then there's going to be an overview page, which is like me sitting there in the lecture hall talking to you guys. So that's where most of the content will be. The one below it is the lab manual that I'll have printed out and shared with you. And I'm going to likely be posting drop boxes if there's an assignment associated. So that's where that stuff is. But in the overview page, if we go to that, this is going to largely be the background, you know, content of this assignment and this module. So we talked while we were on the field last week about you guys kind of acting as the foragers, pretending like perhaps you're a chipmunk or a squirrel, and that, you know, we don't live alone. We're going to have other organisms around us that are going to force us to eat in a different way, or eat at a different time, or eat in a different place, so that we don't get eaten if we're dealing with predators, and we don't get frostbite if we're dealing with cold weather and that sort of thing, right? So we talked about those biotic and abiotic factors, which you then later simulated. And then we also mentioned this idea of optimal foraging theory, which is coined by these guys. So Shelby, I think you know, when you were talking about articles, one article that everybody should really be pulling in is this classic article right here. These are the guys that coined the term. And if you click on that, it'll bring up the classic article talking about optimal foraging theory. We mentioned, and maybe you guys even demonstrated this on the field, that usually the strategies are you're a specialist or you're a generalist, right? And if you're a specialist, you're going to eat one thing well all the time. So you can think panda would be a good example of a specialist. What they're doing to become efficient foragers is they are getting really good at handling the food. So they're reducing their handling time because they eat it all the time. They get used to processing it. And they are probably reducing their search time because they know what it looks like. They've gotten really good at finding it, right? The travel time is where they might run into trouble. They might have to go very far to a patch. So again, a forager wants to reduce the amount of energy it expends while gaining the maximum amount from the food that they eat. So that would be the choices of the specialist. A generalist is gonna maybe be uncertain whether or not their favorite food is going to be available to them. So as a result, they're going to eat whatever is near them, right? So in essence, what they're doing to reduce their energy expenditure is to travel less far. So they're reducing travel time, right? So they can access whatever they want. However, what they're trading off there is their handling time. They may be really good at eating red oak acorns, but not so good at eating white oak acorns. And so it might take them a little bit longer to process the food. So they're reducing travel time. They maybe are reducing search time because they don't care. They're taking whatever is nearby, and they're maybe adding on some more of that handling time. So it's really a trade-off of those 3 times: travel, search, and handling time. Okay, and so those are the 2 major strategies. That's all kind of good intro level background stuff. And then we went and did our awesome experience. Look at you guys, you're all famous. I built you all into the Moodle site, right? So for those of you that need a refresher, I put in all of our visuals here. There was some intense foraging on the field the other day. I'm in class. I'm in my class right now. Sorry, guys. Okay, so you guys know that you can always go back and you can see all that stuff, right? So we're going to keep scrolling down, and now we are at week 2. And week 2 is, what does this all mean? How can we analyze this, right? And so there's 2 items that you guys can click on, whether it's now or later on your screen, and kind of follow along as we go through data analysis. This optimal foraging raw data is consolidating the stuff you wrote on your tables with our section, as well as Dr. Lesser's section that happened the next day. Okay, so we wanted you to have a larger data set. And then right below here is the link to the rubric for the writing of the whole paper. And then I portioned it out for part 1 and part 2. You guys are doing the part 1 right now, and due next week will be the part 2. So the results and discussion and abstract. So we can talk about that a little bit later, okay? So if you guys want to, you can minimize me and kind of back and forth, but really this optimal foraging raw data might be one that you want to have up in your background and saved onto your computer. I think it's going to open it up in maybe a Google format, like a Google sheet format, but you'll want to download that and save it as an Excel file, because we'll be working in Excel today. Any questions on that? Okay, and if we scrolled a little bit farther down, again, for those that didn't see these are the example articles that might be useful as you guys are building them. And it's not to say that you need to always use these. They're just, you know, ones to get you started. You can look at their bibliography at the end and might be able to find some other useful articles. They're a little older now, so again, doing your own search in Google Scholar would probably be a good idea as well, okay? All right, so without further questions, what I'm gonna do is I'm gonna switch over to our actual data set, okay? And I don't know how to hide this. There we go, okay. So now you guys see it full screen? Okay. Taylor, give me a heads up, yes? You guys are seeing it all full screen?
Yep.
Yeah.
Okay.
Yes.
I'm not seeing you anymore, so I'm gonna need you to speak to me a little. All right, so what we did is we organized your data into the raw data tab, okay? And let me just orient you to the sheet, okay? And optimal foraging trial 1, there were 18 foragers. That includes not just our class, but the class after. Dr. Lesser, I think, didn't have everybody do every trial because he has fewer students. And that's why we only have 18, and you'll see 34 in some of the other trials. So each one of this represents you. One of these is you, okay? And if you remember, you were out foraging for white, red, and blue chips. These were the counts on the numbers, white, red, and blue. Then you added them up both sides. You got total calories for those colors. And ultimately, these are the 2 calculations that we're going to be covering. Total calories for each forager and total calories per chip, okay? This over here is just our summary table. That's going to help in building our graphs later on, okay? So there's nothing we need to do with that. It should autofill as we begin our calculations. And if it doesn't, we'll just paste it in, okay? Now, I mentioned that we're gonna be doing 2 statistical tests. One is a chi-square test. It's a goodness of fit test. And it is determining if the observed number of red, white, and blue chips equals what is expected. And where do we come up with those expected? So this might be something for you to note in your notes, okay? And you might remember, because we were counting to make sure we had the right numbers in the bag at the end, right? So there were 40, if you recall, 40 white chips in the bag and 20 of each of those other 2 colors, 20 reds, 20 blues. So proportionally, 50% of the bag, or 50% of the chips that you flung out onto the landscape, should be white, if you just foraged at random, kind of random chance as stuff is found on the landscape. Whereas 25% of the time you should pick up some reds and you should pick up some blues. So we're gonna figure out what our total number of chips are, and then we're gonna multiply the total number of chips by 0.5 or 50%, and that's gonna give us our expected number of white chips. We'll take that same total number of chips for this entire trial that was run, and we will multiply it by 0.25 and get the number of reds, and do the same for the number of blues. So those are our expected number of chips. The observed number of chips will simply be the number total of all the red chips and white chips and blue chips that we found. So we will come up with that and we'll paste those across. So what a chi-square test will do is it's gonna compare your observed minus your expecteds. It's gonna then just square that. That's gonna be the numerator of your chi-square test. And then it's gonna divide it by your expecteds, okay? And I've basically broken out the calculation into small little steps that we can do in Excel, okay? So if I were to like go back here and Google chi-square calculation, just so you can see what it looks like. This is somebody's handwriting here. It's the sum of the observed minus the expecteds. So that's squared divided by the expecteds. So every little step on the left-hand side column is calculating this equation. It's getting us to calculate this equation. The final step sums the little chi-square for the whites, the little chi-square for the reds, the little chi-square for the blues into 1, okay? That value is going to be compared to a value from this table, okay? And the value from this table is our critical value, okay? How do we arrive at this critical value? So this is basically saying, are we foraging optimally or are we foraging randomly, okay? You guys probably remember from statistics, what do we usually use as our confidence interval? Is it like 80%, 70%, 90%, 95%?
95 usually.
Yeah, you got it. So 95% corresponds to this 0.05, okay? So we look down the 0.05 column and then we have to figure out what the heck is the degree of freedom. In the case of our experiment, the color of number of chips, so basically we have red, blue, and white. That's 3 variables minus 1, so our degree of freedom is 2. So we look across the row of 2 and down, and we get a 5.991, okay? So we have figured out that at 95% confidence, we looked at 3 different colors, so it's degrees of freedom minus 1. That's just by definition what we have to do. We figure out where those 2 meet. It gives us a critical value of 5.991, and our grand chi-square sum that you guys are calculating right here, right in this cell, is the mini observed minus expected squared of whites, observed minus expected squared divided by expected of reds. Same for the blues. We sum those 3, we take that value and put it right here, and we compare it to 5.991, okay? That is our decision rule. We make a decision, and it's important to note what it is we're deciding, right? So our null hypothesis is that our observed number of chips equals our expected number of chips, okay? All this is in the lab manual data analysis section. But basically, we're foraging at random. If we pick up, you know, the same, and that's our observed is what we pick up, right? If we pick up the same ratio as what we found in the bag, what is to be expected, then we were probably foraging at random, right? But if we picked more blue chips than we do the whites, which I think in the end, maybe you guys were doing, then this result might be really high. Our chi-square value might be really high compared to the cutoff critical value. And then we would reject the null hypothesis because there is a difference in observed versus the expected chips in favor of an alternative hypothesis, which is optimal foraging. Okay, so we'll go through this and kind of revise, you know, make sure it's firm in your minds. But basically, we're trying to determine if we've really strayed from what's expected on the landscape, which would be us foraging like at random. If we come up with a chi-square value that is way greater than the 5.991, we reject the null hypothesis that the observed and expected chips are the same, in favor of us optimally foraging. We changed our strategy to be better at managing whatever stress we encountered. If our value ends up less than 5.991, we failed to reject that hypothesis. So we could very well have been foraging at random as stuff is found on the landscape. Does that make sense to everybody, kind of? It'll make more sense as we go through as well. Any questions so far? So that is we have to do this for every little trial. So we've got the optimal one. We scroll down a little bit more. We've got predation. And that's the one where we had 34 people doing it. We've got winter or harsh weather, exploitative, contest or interference competition, scavenging. Each one has its own little chi-square, and then experience or learning, okay? So I'd like to begin with you. We can kind of, you know, work through this together, just so, you know, you're feeling comfortable with this, okay? We'll kind of walk through the rest of these tabs as we go, okay? All right, and feel free to ask me a question. I don't know how much experience you all have with Excel. How many of you guys have used Excel?
Never.
Never?
I have.
I rarely use it like for stuff like this.
Okay, all right. Well, times are changing. Excel's gonna be your friend. So definitely in STEM, this is like one of the go-tos, and it's ultimately these formulas that we'll be using are gonna help make life a lot easier, okay? So feel free to jot some of these formulas down. I'm gonna post this Zoom video for you guys on the site. If you need to go back and refer to it, you can do so, okay? So the first thing I want us to do is I want us to go over and fill in our total calories. So for those of you not familiar with formulas, we can just click on the cell where we want the formula to go, and we can grab this little corner, there's a little square right there, and drag it down usually to do the calculation for us, okay? So for total calories, we want to associate with the calorie columns, right? So that's C, E, and G. So what I'll do in this cell is do equals sum, open parenthesis, and then I'm gonna click on my calories white. I'm gonna hit my control and click on the calories red, keep my finger on the control button and click on the calories blue. I can end my parentheses, but sometimes Excel is okay with just hitting enter. And there we go. So in one fell swoop, and you can always go back and click on it and you can see your formula up here, is I did equals sum, open parentheses, and then I clicked on what I wanted to sum up. Calories white, then I hit the control so I could click on multiple things, calories red, and then calories blue, and then you can end the parentheses, but in this case, Excel did it for me, okay? Now, rather than have to do that with every single one in that column, you can grab this and drag it down. Beautiful, right? Okay. All right, now calories per chip. So for the calories per chip, we need calories to be involved in the numerator, right? So you can do equals. You can click back on your total calories for that particular person, and you can divide that by the sum of your chips, okay? So hit Control and click on the white, the number of red chips, and the number of blue chips. This time I want to end my parentheses to not cause any trouble. Okay, and let's go back and let's look at that formula, see if it makes sense to everybody. So the column header is calories, so we need to make sure we refer somehow to the calories for that forager. And so I did equals, and I clicked back on the calories for that forager. I hit the divide sign, which is the slash, and I divided it by the sum of my chips, right? So you need the count of your chips. So you can do sum of open parentheses, click on the whites with your control button down, click on the reds, and then click on your blues, and we get 37.5. So on average, forager 1 grabbed about 37.5 calories with every chip that they foraged for. Again, we can drag that corner down. And there we go. Any questions so far? Okay. Now, totals, that's fairly straightforward, right? We go back over here, equals sum, and we grab what's above it. We can just highlight what's above it and drag the corner all the way across. We're going to leave this one blank. Just double checking how it looks over here. I'm going to leave that one blank. Okay, now total calories and total chips. The things in yellow are super, super important. So we did these two calculations mostly to arrive at these two values, okay? So for total calories, this is for all the 18 foragers. And so we know that the calorie columns are C, E, and G, okay? So for total calories, in this case, we can do equals the sum of this, hit your control this, and your control here, and it's the same as right here. So we could actually have just done equals and click on this total calories right here, okay? Total chips equals the sum, and now we go to the chip columns. Click, click, and click. Good? Any questions? All right, now those values we want to copy and put in our organizing table right over here, okay? This is where we're building our graph, okay? So we'll take care of that stuff in a little while. First, let's take a look at our expecteds and our observed. So remember I said the expecteds, the expected whites, okay, will be 50% of the total chips that we captured, everybody captured, like total of this whole trial. So in this case, the total number of chips that everybody captured is 354, okay? So for the expecteds of whites, that's 50% of 354. So I can click in the cell here, equals, click here, hit the times button, which is, shift and the 8, and I can just type in 0.5, 50%. So that should be 177, okay? For the reds, 25% of that, so equals, click on your 354, hit your times, and in this case, it's not 50%, it's 25%. Everybody following along okay? Mm-hmm. And blues will be the same, right? Equals, click on your total chips that you got, times, and that also is a 25%, okay? So we predict this is what we probably would have, experienced on the landscape. And in terms of what we observed, we go up and we take the total chips observed of those 3 colors, okay? So in this case, we can do equals, we had 142 whites. In terms of the reds, we had 88. And in terms of the blues, we had 124. So already you guys can kind of see that we've strayed a little bit, right? All right, so now we're down here. We're working our way through our chi-square test, testing that null hypothesis that we observed what we ate or observed what was expected. So we're kind of feeding at random. That's our null hypothesis. So our next step is to kind of keep building that numerator on this chi-square. So we'll set up the formula equals, and then you click on your observed, minus, click on your expecteds. Okay, and now remember, we can drag that across. If the formula is going to happen the same way, we can drag it right across. Now we're going to just square that value, okay? This is now completing what is of the numerator in the chi-square. So equals, click up here, caret 2, that squares it, and we can drag that across. So now we have squared our observed minus our expecteds. Now we want to divide that value, which is right up here, by expected. So we just do equals, click on that, that's the numerator, right? Hit the divide sign and click on your expected. And you can drag it across. Now, for those of you kind of new to Excel, let's just kind of click in the cell and look at what it did, right? It is going to change your values, so cell B28 and B25, okay? B28 is your numerator, B25 is your expected. When we switch over to the reds, notice the formula has updated. It has kept your rows the same, but it has changed your columns, right? Which is what we wanted it to do. So it moved over and grabbed from the red column. And now the next one should reflect D's, right? Moving over and grabbing that. So what we've just done is we've made little mini chi-squares, right? Observed minus expected squared divided by expected of the whites, the reds, and the blue chips. And so this yellow area right here, I call it the grand chi-square. And so we're basically just going to sum up those 3 little mini chi-squares and see what we get. Drum roll, we're going to hit that. Bam. Okay, so what is this telling us, you guys? We're above our critical value. Do we accept or fail to reject the null, or do we reject the null hypothesis? You guys remember?
Do we reject it?
Yeah, awesome. So our cutoff is 5.991. If our chi-square, grand chi-square ended up being less than that, then we fail to reject the null. We very well could have been, that basically means we accepted it. We very well could have foraged at random, just as the chips were found in the landscape, because our values, these observed and expecteds, were quite similar, right? But the fact that we are way over, I wouldn't say it's way over, but we are over means that we did something different. Our observed strayed from our expecteds more than statistically okay. And as a result, we're going to reject that null hypothesis that observed equaled expected chips in favor of our alternative hypothesis, which was optimal foraging. We did something a little different. Now, right off the bat, you guys might not even have realized that you did that, right? And, you know, so it's hard to know if this was kind of a one-off thing or not, because you didn't know that those colors had different values, right? But in general, this little area right here is where we're going to write our decision rule. And in this case, we decided we're going to reject the null. Okay. Now, mean calories per forage or mean calories per chip. I want to just check over here. Okay. Our mean calories per forage or mean calories per chip. Again, these are what we're using to build the table. These are the calories per forager. Okay. Now, instead of doing the sum like we had been doing, right, we're going to do the average, okay? So in this cell, we can do equals average open parenthesis, and we can average the calories for the foragers, okay? So we're averaging the total calories for each of our 18 foragers in this case by using equals average and grabbing the data as opposed to using the equals sum, okay? And over here, we're gonna average the calories per chip. So equals average, and we're gonna grab that column right here. Okay, seems about right. And now we want to make sure that we have an associated error bar, okay? So we're gonna actually use standard deviation, and it's pretty straightforward as well. So equals stdev, that's this abbreviation for standard deviation. And this is the one for the calories per forager, right? So we go and grab these again. Don't grab that bottom one, which was the totals. That seems a little off. Equals stdev. Maybe I grabbed too much. I think I maybe grabbed, nope. Maybe there's a lot of variability there. Okay, let me just double check. Yeah, so there's a ton of variability. We were all over the place on that. That just seemed kind of odd to me. Any questions so far? It's a lot, but we're going to be doing this repetitively, so it should be more clear. Now, if you look over here, the table is auto-filling for us, okay? And it's basically going to help build our graph. This is the mean calories per forager, and we're going to have mean calories per chip afterwards, okay? And you can see here, we rejected the null, right? Okay, with no questions, we'll move on to predation risk. You guys good so far? We're kind of in reinforcement phase, hopefully right now. Okay.
Yep.
All right, so we're at predation risk. This is when you guys whacked each other with the balls. And so we're gonna be summing up the calories that were acquired by each of these foragers. So equals sum. And we're going to do the calories, not the counts of the chips. So we click here, again, we hit our control button, okay? And we can bring that all the way down. And in this case, we had more foragers. We had a lot more foragers this time. And in terms of calories per chip, equals, got to hit the calories, divide by the sum of our chips. So hitting the control on those, ending that parenthesis, and that looks about right, right? Because most of your chips were like 10, 20, 30, right?
Yeah.
Okay. All right. Totals, that was an easy one, equals sum, and we're just going to grab the column above. And then you can drag that corner across. So that was easy, right? Now total calories for everybody should be equals the sum. And again, we could sum up the end column that we have in bold for the calories, but didn't we find out that it was the same as this, right? So we can go back and just do equals and click on that. Okay. Now we need total chips. For that, equals the sum, and we're clicking on the chip totals. All right. Moving on to our chi-square. We've got expecteds and we have observed. So we could just bust out the observed, right? So the white column was right here. The red column is right here. And the blue column is right here. And now we need to know, well, what did we expect for the whites? So 50% of our total chips. So equals click on your total chips, times 0.5. And then equals for the reds, click on your total chips times the 0.25. Okay, and it's the same thing for the blues. All right, now we're going to do equals your observed minus your expecteds. Whoops.
Wait, I have a quick question about the expected.
Sure,
So,
sure.
how did you do that again?
Yeah, hold on one sec. I grabbed something that I should not have. Okay. Yep, the expecteds?
Yeah, the expected.
Yep. So for your expected, imagine you're holding the baggie in your hand, and on the outside of the baggie, it said 40 whites, 20 blues, and 20 reds. So what that means is, however many total we had in the bag, or however many total everybody in the whole, survey, however many chips that they pulled, we would expect that 50% of them, right? Because 40 is 50%. We had basically 80 chips in the bag, right? 80 chips in the bag. 40 of those chips, or 50% of them, were white. 20 of them, or 25% of them, were red or blue. Should show up as being those colors, right? So you basically, for your expecteds, you go over to however many chips everybody in the entire survey, including our lab and the lab next day, got, which is the total chips, and we multiply it by 0.5 for 50% for the white ones. And then next to it, we go and grab the same ones, the total number of chips, and we multiply by 0.25, right? Because a fourth of the bag. And then over here, the same thing. So 25% of the bag, or whatever you pick up on the landscape, should be blue, 25% should be red, but 50% should be white. Does that make a little more sense?
Yeah, that does. Thank you.
Yep. So it'll always change. It'll always change as a function of how many total chips you had, but we'll always be multiplying by either 0.5 or 0.25. Okay. All right. So now we're going to move forward, and we're going to do the observed minus the expected. So equals, click on the observed, minus, click on your expecteds. Okay, and drag that all the way across. Now we're going to square that. So we go and we can grab the O minus E. All we need to do is use the little caret 2. And we can drag that all the way across. Now we're going to do the same thing. We're going to click above. And this time we're going to divide it by our expecteds. And drag that all the way across. Now remember, this is the mini chi-square of the white, observed minus expected squared, divided by expected. Same for the red, same for the blue. And now we need to get the grand sum, right? Which is the sum of those mini chi-squares, equals the sum of these three. Ha! What do we see here? What did we do with predators?
We failed to reject.
Yes. So you guys totally foraged at random. I don't know if you panicked or what. So here we have fail to reject. Okay, good stuff. All right, so mean calories per forager equals the average of our calories per forager. And the mean calories per chip equals the average of our column of the chip ones. It might not like that divide by 0. I gotta go delete that. Sometimes that will happen. We had some zeros where we just weren't able to, somebody didn't get any of that particular color. Okay, so I just went through, anytime you get that, you can delete them. All right, now standard deviation, STD. And this one is of the calorie per forager. So we go and grab that again. And then this one, STD. Oops. Okay.
Can I just have one quick question? How did you get the x squared?
The what squared?
The
This one?
no, I think it was the last one, the one before the critical value.
Right here?
Yeah, that's the one.
Oh, yeah. So it's hard because I don't have a dry erase board, but the chi-square, the word chi-square, it's a symbol and it looks kind of like a cursive X. Okay, so that big X that I have right there is really like just the symbol of like chi-square. This is our chi-square value. And I call that our grand chi-square. The grand chi-square value comes from the sum of these mini chi-squares. Okay, and remember, I'm going to go back here real quick. Remember when I Googled like chi-square calculation? And I pulled up some guy's handwriting, right? Actually, it looks better here, more professional, okay? This thing right here means sum, okay? We do in our little Excel sheet, right? We have the O minus E, then the next row we square it, then the next row we divide by the E again. We do that, this whole thing right here, we do that for the whites, we do that for the blues, and we do that for the reds. Then we sum each one of those. So I was calling these little mini chi-squares for each color. We sum all three of those and we get a grand chi-square. And that's what, see right here, how I made that big X? Imagine it's that cursive thing. That's really like what the symbol is for the term chi-square. Does that make sense?
Uh-huh.
Okay, sorry about that.
That's okay.
Yeah, I didn't bring in the actual symbol, but okay. And so again, we've got a pretty high deviation here, but we're going to see when we scoot over that you guys ate more with the predators. So it's interesting how this is kind of playing out right now. Any questions so far? Okay. Getting the hang of it? All right, we'll keep going. All right, winter weather, right? This is where I taped your hands so you couldn't even move your fingers. All right. If somebody's typing on the computer, if you guys could mute the typing, that would be good. So here we've got total calories again. So we're going to sum up our calories. So we're going to click here, use our control to click the rest of them. We're going to grab that corner and drag it down. Our calories per chip, meaning we need to go and grab our calories and divide it by the sum of the chips. So we use the control button and grab the sum of the chips. Okay, and we can drag that down. This time it looked like people were eating maybe a little bit more. Okay, and now our totals equals sum, and we grab those. You guys feeling a little better about your formulas now? Little?
Yep.
Okay, grab that corner, drag it across. Okay, total calories, that one was easy. Remember, we could just refer to the total calories over here. So equals, and then click on that. Total chips, we did equals sum, and we clicked on our total chips here. Okay, and that total chips becomes important when we do our expecteds, right? We just learned that earlier. All right, so our observed whites equals, click on our whites. Our observed reds equals, click on the number of reds we got. And these are total chips equals, click on the total chips blue we got. Okay, and our expecteds then, who asked me that question? You guys remember? Who asked me the question about how we come up with the expecteds?
I did.
It was, okay, so tell me, what do we do? What are we grabbing first for those expecteds? I put you on the spot. Anybody else can spot?
Yeah.
So we need our total chips, right?
Yeah, so you take the total chips and then you divide it And you multiply by 0.5.
Woohoo! You got it. Yes, yes. So equals, click on your total chips times your 0.5, 50%. Beautiful. Good job. Now for the reds, grab that total chips again. What do we multiply by now?
0.25.
Yeah, 0.25. And same deal, we could type in 32.5 or we could just set up the formula. I always like to kind of be consistent with the formula in case we ever needed to drag stuff down. Okay, now we're building the numerator in our chi-square right now. So equals your O minus your E. We're going to drag that across. Now we're just going to square that. So we go grab it and use your caret 2 to square it. Drag it across. Now we're going to take that value that we just did for the numerator, so equals, click on it, and divide it by our expecteds. Drag it across. And now for whoever asked what that meant, right, these are my mini chi-squares, one for the white, one for the red, one for the blue. We will sum them up and get our grand chi-square. And that's our evaluator, right? Whoa. What happens here?
Reject the null hypothesis.
Yeah, so we reject. We totally foraged optimally. We did something here that made that happen. All right, mean calories per forager. This is what we want to graph. So we grab all those calories per forager. Whoops. Ah. I'm gonna hit my undo button here. Ah. That, so you guys see that backwards arrow that I hit up there? That might become your friend. Every once in a while your keyboard goes a little funky. All right, so we're going to average those, and then we're going to average, whoops, our chips, calories per chip. Okay, and now standard deviation, STDev of those same columns. Okay, all right, now it's probably building it for us. So we'll go up and look. All right, here's our winter, harsh weather, winter weather. And we can see, I don't know why these old ones are kind of carried over here, but they'll shift in a minute. So harsh weather. Harsh weather, really, I really taped your hands pretty good, I guess. So the mean calories per forager was way low on the harsh weather, okay? And we definitely, you guys definitely, you know, picked and choosed accordingly as a result of that. All right, we're getting closer. All right, total calories equals our sum of our calories, right? Should be easy for you guys now. And drag it down. Calories per chip equals, click back on those calories, divide by the sum of your chips. And drag that down. Sum up your columns equals sum. Once you have that first one, grab that corner, drag it across. Total calories equals the sum of my total calories column. Total chips equals the sum of my chips columns. Okay. And now we're moving down here. Our observed whites equals, let's click on our white, equals, click on our red, equals, click on our blue. And here we're gonna go grab our total chips that everybody got, multiply it, as you guys told me before, by 0.5. Here we're gonna multiply it by 0.25. And here we multiply by 0.25 as well. Okay, O minus E, observed minus, click on your expecteds. Drag that corner across. Here, we're going to grab that value and caret 2 to square it. And here, we're going to grab that and we're going to divide it by our expecteds. Drag that corner across. These are our mini chi-squares. We're going to sum those 3 up for each of the colors. We get our grand chi-square decision. What do we decide? Anybody?
Reject it?
Yeah, reject. Thanks. Okay. All right, so these work the same way as usual. We're averaging our calories. We are averaging our chips, calories per chip here. We are doing standard deviation of those as well to get our error bars. Okay, let's see how that one looks. All right, so we ate more with competition than we did with harsh weather, but we didn't eat as much as we did with predators. Okay. Only a few more. Equals sum. All right, we're on our contest competition. So you guys rock, paper, scissors, right? So whoops, I'm going to click on our calories and then use the control to click the other calories. Here we want to click on that and divide by the sum of our chips. End the parenthesis. Okay, we can drag that down. We can drag this down. And now we're just going to get our sums. Open parenthesis, grab the column, drag it across. We've got a division by 0, so in anticipation, let's just get rid of it. All right, total calories equals, we click on our total calories right over here, the sum. Over here, we're going to do equals the sum of our chips. Okay, that becomes important down here, right? Because that's going to be our expecteds. So equals the observed whites equals, oops, our observed reds equals our observed blues. And now our expecteds will be your total chips times your 0.5 on the whites equals the totals times your 0.25, 25% of the bag, and so on here.
Professor, quick question.
Sure.
Did we reject the null for trial 3?
I think so. Let's go back up and look. So we rejected there. We rejected there. We failed to reject there. And we rejected there. Why is that kind of jiving with you?
Sorry?
That's making sense to you now?
Yeah, it's just, sorry, I'm really slow. I'm still working on like trial 4.
Oh, there's no worries. There's no worries at all. This is all being recorded, so you can go at your own pace. I just wanted you to have a reference and us kind of walk through it together.
Okay, thank you.
So yeah, there's no worries. If you fall behind, it's probably better to just watch and kind of absorb it, and then know this will be posted and you can pause it and watch it and keep going back to your own sheet at your own time. Okay, I'm sorry if I felt like, you know, don't feel pressured. You'll always have time to go back. Okay.
Thank you. Yes.
Yeah, no problem. All right, so we're back down here. We're gonna do our observed minus our expected. Click on the O minus the E. Drag it across. And here we're going to just take that value and square it. So our goal really, you guys, is to make those two graphs, okay? We want one for cows per chip, we want one for cows per forager. And now equals this divided by our expected. That's our mini chi-square for the white. It's going to now calculate for the red and the blue. And then the grand chi-square, is summing all three of those. Oh, reject again, right? It's greater than our critical value. Okay. So we have scavenging and then we have learning or experience. So we're almost done, okay? Mean calories per forager, okay, equals the average of these guys. And the average over here of, whoops, I didn't finish the sentence. I know, it's it's not as exciting as running around and doing this, but you're gonna have some beautiful graphs in the end that'll help you guys in your report, help you address the question. Whoops. Oh, that one actually doesn't have, remember, it doesn't have anything there because it was a $, pound, whatever the value that it didn't like was there. All right, so let's take a look at how that one looks. Okay, now you guys were there, right? Contest competition was tougher. You were rock, paper, scissoring with somebody. It was tougher than just competing regularly, right? Without coming in contact with each other. So that trend is to be expected. So far what we're seeing is contest competition hit you guys the hardest. That stress made you eat the least so far, right? Surprisingly, predation, you ate well. Any thoughts, as we're just kind of thinking here, any thoughts why that might be?
It was impossible to hit anybody with that.
Yeah, so we had really bad aim or we had really strong winds, right?
Some bad predators, yeah.
Okay, so that is something good to note. That might be an explanation for you when you go in to kind of talk about that stuff. All right, almost. I got to get you guys through the graphs and then into the ANOVA, which is, the ANOVA is really quick once we get there. All right, scavenging. So total calories on scavenging. We want to sum up our calories. We can drag that down. And the calories per chip. We want to grab the calories, divide by your sum of your, of your chips. Yes, I know. Sometimes it confuses itself. You just click on that, divided by the sum of the chip sum. Somebody's got a window seat.
Yeah.
Yeah, must be sunny. All right, so we've got that pound div 0. Anytime you guys see that, just get rid of it because it's going to give us trouble, right? Now we do our equal sums. And we can grab that corner and drag it across. We've got our total calories now, which is just clicking on our total calories over here, right? We've got our total chips is the sum, and we click on our total chip column rows there. Okay, now move on down. What are we observing for the whites? 63. What are we observing for the reds? 50. What are we observing for the blues? 59. Okay, for the expecteds, it's equals, click on your total chips. You guys told me 50%, right? Whoops. It didn't like something I typed. That is not 50, yeah, that's 50% of 172. For the reds, grab your total chips times 0.25. And total chips times 0.25 again. Okay. And now we're going to do the O minus the E. I'm going to drag that across. We're going to square that value. So click on it, caret 2, drag it across. And we're going to square that. That seems crazy. And drag that across. And now we will sum it up. And yes, we will reject that. That's weird.
We're
Yeah,
just supposed to divide that 529 by the expected rather than square it. I think that might be why that value is so high.
Oh, did I square it again? Yeah,
I think you did.
Good call. Good eyes. So somebody is still with me. Thank you. Yeah, sorry about that, guys. I squared it twice because I was like, wait a minute, that seems crazy. Okay, so what I did over here was I squared it, and then here I did the same thing by accident, which I should have done is just divided it. So those numbers look a lot more on point. Thank you for that. So now we've got our mini chi-squares for all 3 colors. We do our equals grand sum, and what do we decide? Same old, reject. You guys optimally foraged, right? You did something different, that these varied enough that it made a difference, right? It wasn't exactly, you know,
Why do you, I'm sorry for the late question. Why do you, how do you do the, like, decide if you reject it or not?
No problem. Yes, good question. So do you remember at the beginning, I pulled up this like old-fashioned
Yeah.
square table, right? We picked the 95% confidence cutoff, and then we said, you know what, we have 3 colors. Our chips are 3 different colors. The degrees of freedom is usually types minus 1. So if we have 3 types or 3 colors, minus 1, that's 2. So find where the 2 and the 95% confidence meet up.
Yeah.
If we had 4 colors, we would be comparing it to this one, 7.815, okay? So we decided based on 95% confidence and a degree of freedom of 2 that 5.991 is going to be our critical table value.
And if
And
it's
then,
than that, you reject it?
Yeah, so anything less than that, so if our grand chi-square is less than that, we have to fail to reject the null, meaning we kind of accept the null, which is that the observed number of chips equals the expected number of chips. Or in another way of saying it, we foraged at random as the chips were found on the landscape. If our value of chi-square is way higher, or anything higher than that, then we reject the null in favor of optimal foraging, that you guys actually did a behavioral change. You didn't just randomly take stuff. You know, the fact that you had predators or you had competitors, you had winter weather made you do something differently. You thought about it, you behaved differently on the landscape. And we see it when we look at the chip ratios.
Okay.
That makes sense?
Yeah.
Okay, good. All right, so means, again, the means over here are what are going to make our graphs, right? Equals average. Over here, we grab these. And over here.
And then when we go to do this ourselves, we're literally just repeating the steps you're doing right now. Like we're doing, copying you.
Yeah, so I'm gonna, don't panic because I'm gonna
Record.
maybe make life easier for you. I'll tell you in a sec. If you've hung in with me for this long, you know, there's probably a good thing on the end of that. Okay, so you guys saw what I just did, right? Standard deviations on those. We've got our averages over here, and we'll go and check out how scavenging compares to everything else. All right. Scavenging did a little better. So you guys on average, each one of you fed a little better than you did. However, you know, not as good as some others, like your predators and your optimal. Okay. All right, we're on to our last one. There is a subsection of predation. You see that tab there where we broke it out by 1 predator, 2 predator, and 3 predators. So we might just check that out real quick too, because that makes the graph really interesting. Okay. So finally, this is you guys learning, okay? In this case, we are summing up our calories. And again, if you go through the lab manual and read over the analysis section, it kind of gives you what the formula for chi-square is. It tells you how we arrived at the number of expected, which you guys know is total chips times either 0.5 or 0.25. It gives you a couple of examples of this. So if you ever needed to see the rationale, you can also go back there. So now we're dividing it by the sums of our chips. Okay. Grab that, drag it across. So we just summed everything. Total calories would be the same as the end of our total calories column, right? That's because we summed it all up there. And the sum of our chips, we just grab, using that control button, our sum of our chips columns. Alrighty. We go over here, the observed, which is what you collected, whites 43, red 77, and blue 149. Wow, I think something's going on here. Now for the expecteds, we click on our total chips. You guys said times 0.5, total chips times your 0.25, total chips times your 0.25. We're just going to subtract those two. Click on the O, minus, click on the E, drag it across, equals, click on that, square it, drag it across, equals, click on that, divide by the expected, drag it across. And those are our mini chi-squares for each color. Now we want the grand chi-square, we sum them up. Wow. So you can even see like the significance kind of by how far you're going over that critical value, right guys? So in this case, you guys were totally like, you totally learned, right? I hope. Or you were just so fatigued that you, something happened and you picked the right ones maybe. Okay, so in this case, we also reject, right? All right. So mean calories per forager, finishing up the major part of the graph here, equals average in this column equals average in this column, the standard deviation of that column, and equals standard deviation, oops, of this column. All right, let's see what we got. Huh, interesting. So you did better than some of those other trials, but you seem to do better in your optimal when you first started out. There could be a fatigue factor here, right? Kind of think about what might have been going on for you personally at that point in the day, right? You were probably tired, maybe thirsty, maybe just done with it, right? And so that could have played in. However, you did do better in foraging than all those other ones right here. okay? You'll notice there's an absence here of the 1 predator, 2 predator, 3 predator. And we're also missing the graph that I want for the chips. So let's just finish off with completing these predators here, okay? Notice there's a predation tab, and the predation tab is quick. There's one for 1 predator, one ball, 2 balls, and 3 balls, okay? So let's just fill those in like we were doing. Now we're going to see if like being a group or a pack hunter had something to do with this, right? So calories. Chips. And your sum. Easier when it's compact like this. Now you've got your total calories. And now we're doing our sum of our chips. Okay, means, whoops, got a lag time here with my computer, I think. You don't want to grab the totals. Standard deviations of the same. Okay, now what we need to do, you guys, is something I want to make sure you're kind of cued into, okay? Let's see. Grab these, do a Control-C, which is copy. Go back over to this tab, go up to our table, and sit it right here. Oh, it's filling it in. Let me just show you, though, if it didn't autofill, okay? I'm going to put my cursor where I want to paste it. And notice I copied something that was vertical, but I want it to go horizontal, okay? So what I would do is I would sit my cursor right there. I would right-click and go to Paste Special. Just kind of showing you this because it might be useful down the line. You can hit Paste Special what? You want to paste values, and you want to transpose it. Transpose means it's going to run it from going vertical to the opposite. Okay, and then it's going to run this way. Good? We can do it again for the other one too. All right, so let's first just kind of bust these out. So 205, observed whites, observed reds, and observed blues. Our expecteds will be total chips times your 0.5 equals the total chips times your 0.25. Oh, that one was on point, equals total chips times your 0.25 again. Drag it across. That and square it. That and divide it by expected. Aha. Tiny. What's our decision?
Reject.
Fail to reject.
Yeah, fail to reject. So we kind of foraged at random, right? In this case, we ate as it was found on the landscape. Maybe everybody panicked who had just one predator. But that is something, you know, something to note. So we go over here. Let's see if adding another predator changes how we behaved. Oops. I didn't mean to do that twice. Whoops, I grabbed the wrong columns. Okay, I needed to grab the chips. That's better. They're usually around 30 to 40, right? Okay, we have another divide by 0 that we're going to omit. We're going to do our totals, the sums, drag it across. Okay, our total calories will be right there. And these total chips will be right there. All right, we could easily do these at this point, equals the average, since we're looking right at them. Average of our cals equals the average of these guys equals standard deviation of the cals equals standard deviation of the cals per chip. And now over here, the observed whites, 73, the observed reds, 48, the observed blues, 56, our expecteds, grab the number of chips times 0.5, grab the number of chips times 0.25, and the same thing okay, equals observed minus expected, drag it across, equals that, and we square it, and equals this, and we divide it by our expecteds. Oh, looks like a little value. And we sum those mini chi-squares. Oh, we're just shy, right? So we're kind of at the cusp here, like we were on some of the others. But decision?
Reject the null.
Yeah, we're still going to reject. Okay. All right. And I think it's filling in, so we're not going to go back and look, but we'll just finish this one up. Equals the sum of our calories. Drag it down. Equals this divided by the sum of the chips. Oh, it's because we started off with one that had a 0. So we're just going to get rid of that. But build the formula in that cell, and you can afterwards, after you've dragged it down, get rid of it. If you guys saw what happened. Our first cells happened to be all 0s. So it gave us that error. But you build your formula, drag it down, and then you can clean it up afterwards. All right, total calories will be right there. And our total chips, the whites, the reds, the blues, our means, we could do that right away, right here. Standard deviations. Okay, our observed is 54. You guys can also just type numbers like this in. Again, I just want to get you used to kind of the formula process, because sometimes they tie to it directly. So typing in a number will omit your ability to just drag stuff across. All right, your expecteds. You go to your total chips times your 0.5. Your red expecteds, total chips times your 0.25. And your blues, total chips, times your 0.25. We're gonna subtract those, drag it across. Anticipation, and take that and square it. Take that value, divide it by your expecteds. It's looking small. Ah, got a little bigger. Sum those mini chi-squares. And last but not least, we reject the null. So we can go back to the raw data. It should be auto-filling, so it auto-filled our table here. And let's see what we've got. Okay. So optimal conditions, you guys didn't have any threats, right? You ate pretty well. With one predator versus 2 versus 3, that trend is fairly clear, right? You would think with 3 predators, more opportunities to eat you, you probably were more vigilant, maybe you were behaving differently, you ate less food, right? You probably lost chips as a result of injury, right? This is just, we didn't pull apart, we just put everybody who had a predator rep, we put everybody together. So, you know, when you're thinking about comparing optimal conditions, which is like our reference or control, to predation, you could first kind of talk about predation generally with the all predators. But then you could say, and it was much worse, like how many times worse? Like almost twice as worse? Actually, it better, right? You ate almost twice as much with one predator as compared to 2, and a third as much as compared to 3. So the more predators you added into the system, the less likely you were to eat, right? So when you're kind of trying to explain things, that's like a way to deal with it. So think of your optimal as your control and compare what's going on with the predators to that of the control. Compare what's going on with the predators to that of the harsh weather, right? How much less did you eat with harsh weather than you did when you were in optimal conditions, right? Now compare your optimal conditions to the 2 types of competition. You could do that in one sentence, just like you could do this to the predators in one sentence, okay? Obviously, exploitative lets you eat a little bit more when you struggled with someone and had direct contact. Your yield of energy was less. That kind of makes sense. Now you do optimal versus scavenging, right? What's the trend there? Why would you have eaten less with a scavenger? And then with learning is kind of confounded. What are you guys thinking? How would you explain learning in this situation? Because what would you have predicted?
We would have predicted that it would have been higher than optimal, but I think, like you said, we were. It was like the last thing that we did. So
Yeah.
Yeah.
I agree. I think that's probably a good way to help explain it. If you were to break it apart by color, you might think to yourself, yeah, we ate more blues, but we were tired, so we didn't eat as many blues, right? And just kind of think about what you personally did on the landscape as you're trying to kind of explain that in your discussion section. You know, you can say we ate better than some of those other trials. However, we would have predicted we were, more than optimal because it was the same thing repeated, but we had fatigue to think about. And as a result, we might not have ran as fast. So the number of times you went out to pull those 2 chips might not have been as many. And so fatigue does definitely play into it, I think. So that is important. Now, for the report, the first thing that you are reporting is this graph of mean calories per forager. We also need to make another graph, and your lab manual tells you exactly kind of what you need. You need 2 graphs, and you need a table over here that's your decision rule. So kind of go back and check. These chi-square values are the grand chi-square. Remember, we did the sum of the mini chi-squares? And so that first one is right here, okay? Make sure that grand chi-square is reported and the decision rule right beside it. Make sure they jive, because it was auto filling in, right? So we want this table in your report, and we want the two graphs. Here's the first of the graphs, which was your mean calories per forager. Okay, we just kind of walked through the trends there. And then we also want to make one for the mean calories per chip, okay? And that's this right here. So if we grab this, for those of you that haven't done graphs before, hit the control button and grab this and go over to data. Actually insert, I'm sorry, insert your bar graph. Now we've just created, so that was insert bar graph. We've just created our graph of mean calories per chip, okay? I'm gonna scoot it down below here because I want to talk to us about how to label them. Oops. Okay, all right. Now, you've made a graph. We've got all our trials just like before. We don't have a y-axis label. We don't have an x-axis label either, but we have a title right here. If we deleted that title, you can just click on it and delete it. It makes your graph bigger. So we prefer you guys to do that. Don't have an embedded title in your graph. Instead, make sure your graph is active. So click on it, okay? Close that, click on it, and then go over to the Design tab and go to the Add Chart Element, and you can add your axis titles. Okay, so the primary horizontal might be trial. You can type in trial. Okay, and you can again go back to design and choose your vertical. You can type it in the words in here, or you could click in here and type the words. I like to do it here. Mean calories per chip. And hit enter, and it's going to show up. Does that make sense to everybody? So you make your graph, and we did that by going to insert and choosing this after you've highlighted what you want to choose, and we chose a bar graph. Once the graph gets made, you can modify it, and you can do that in the Design tab by going to the Add Chart Element and bringing it in. Okay, so we deleted our header, right, the title it was embedded because it made it smaller, and we added our axes on those to be what is showing up here. Okay, now let's look at this because this graph is different than the other one, and you might wonder what the heck does this mean. There's less variation, right, you guys? So when you kind of scroll up and look at this one, there's a lot more variability across the trials. So the number of chips that each forager picked up is much different than what we're seeing here, okay? So here's what I want you to kind of think in your mind. This mean calories per chip is basically saying, in these trials, I foraged like a generalist or I foraged like a specialist, okay? If you are a specialist, you're grabbing high quality stuff, right? Usually, right? Come Easter time, I'm going after the Cadbury mini eggs, right? High quality stuff. I'm going to go to any of those stores to grab this because I know I'm going to eat the entire bag of them. So if you're foraging like a specialist, you're going to have high calories that you're taking in. A generalist, perhaps some lower calories per chip, okay? So look at the trials with the highest calorie intake. Now there's not a ton of variability as we mentioned, but the ones with the highest are the ones that foraged more like specialists. And the ones with the lower, in this case maybe just the 3 predators and maybe perhaps scavenging, could perhaps have been more of a generalist strategy. Okay, so this mean calories per chip is getting at that, right? Whether your strategy was kind of generalist or specialist. So if your trial, mean calories per chips are high, then that was perhaps a specialist strategy. And if the mean calories per chip was lower, you were kind of at more of a generalist strategy. Up here, though, you're basically getting at your hypothesis. Remember, your original hypothesis in your introduction is which of my trials gave me the most calories and which of them gave me the least. So which of these is more of a stress to me? Is it, winter weather, or is it having a predator that I directly interact with, or a competitor I directly interact with? And so you can already see here, you did best with one predator, and predation trials in general, all predators when we think generally, and the one predator. Learning was good as well, but the worst things, the things that were the most stress for you guys, were contest competition, and harsh weather, and 3 predators, right? So you're kind of explaining in this graph, in your discussion section, why was it? Think back to when you were out on the landscape and these things were happening to you. What did you have to do to adapt to it? What was it feeling like in that scenario? So here you're explaining sort of how those stressors impacted your behavior, and then down here we're evaluating whether or not you switched your strategies across those trials. Okay? Questions so far? Because we're almost kind of done with the analysis. Anybody? Okay. All right. So I'm going to go over to the ANOVA. Now you guys have just done, believe it or not, you've just done your chi-square statistic, right? That was the major thing. You're testing if you're foraging at random as chips are found in the landscape, the null hypothesis that your observed equaled your expected, or if you optimally foraged and changed your behavior as a result of those, different trials that you played out. Now we want to see, is there a statistical difference in the chips across the trial? Is there a statistical difference in those trials? In the mean calories per forager and in the mean calories per chip. So we're going to do an ANOVA here. And remember, the reason we're doing an ANOVA is because we're going to use 1, 2, 3, 4, 5, 6, 7 trials, right? So it's more than 2 trials. If we were going to compare the means in the calories for 2 trials, we would do just a t-test. But because we're doing 3 or more, we're going to do an ANOVA, okay? They're comparing the means within and between those trials to see if the calories per forager varied across those different trials, okay? And so we're going to do an ANOVA, and what you'll probably want to do, might be something that you want to note, again, it's going to be in the video, is that our Excel has a built-in data package, okay? So I want you to pay attention to this. You go over to your file, and you go down to options, if you don't already have this built in, okay? And then you go to your add-ins, and you'll notice there's this analysis tool pack. That's what we want to grab, okay? So we want to manage those Excel add-ins. We're going to hit go, and we're going to make sure that we have checked off the analysis tool pack, okay? So now, when we want to go to data, we can go over to data analysis. This would not show up if we didn't have that plugin going, okay? So we hit data analysis, and we can choose, we want to do an ANOVA, a single factor ANOVA, and we'll hit OK. All right, now it's going to ask us, it's going to prompt us for an input range. Where are the data is basically what it's saying. So we can click on this little Excel thing right here and grab the data. Grab all of it. Actually, even include the headers. You want to include those headers. Okay, so not all. Remember, the predation had a lot more people active. Okay, so you grab all of it, including the headers, and then click on that again. You check that the label is listed in the first row, because otherwise it's going to be like, what the heck, that's not a number in the first row. And then it's going to ask you, where do you want me to plop my ANOVA results? So this output range, okay, you click on the output range, and then you're going to click here and say, where do you want the output to go? You click where you want your output to go. Okay, so again, what did I do? I went over to my files, I went down to options, I went to the bottom of the pop-up window and I said, go to the Microsoft Excel add-ins. I made sure that my analysis pack was secured and hit OK. Then I went over to the data tab right here. I saw data analysis was available over here. And I clicked on it and it brought this window up. I clicked on my input range right here. It lets me select all of my data. I chose to show that my labels are in the first row. And now I'm clicking the radio button to tell it where to spit out the results, okay? I want it to go in that first cell. I'm gonna hit OK. And look at how exciting that is. You guys didn't have to do a thing, right? Okay, so what is most important to us? It's this area right here. I'm going to change the color. What does this tell us? Our p-value, remember we talked about p-values, p is less than 0.05, there's a statistical difference, okay? This is 3.9, and then it's, you know, backwards. So you've got the 0.0000, there's like 6 of those, right? And then the 3.9. So we are definitely statistically, there's definitely a statistical significance here, okay? Anything less than 0.05 means there's a statistical difference. The fact that your F statistic is above your critical means there's something going on. There is a difference in whatever it was that we compared. In this case, we compared calories per forager. There is a statistical difference because our p-value is less than 0.05. And we can see that our value that we calculated for the ANOVA is greater than the critical value. So we know that there is a difference in the mean calories per forager across these trials. We don't know where the difference is. It could be that scavenging and learning are the same, but scavenging and learning compared to contest competition is where the difference is. So in this case, we'd need to do further analysis. We're not going to. All you guys need to report is your p-value, okay? The p-value, your F statistic, and your degrees of freedom. I like to report the total degrees of freedom. Okay, so in your report, you would say something like this. There was a statistical difference in mean cals per forager across trials. And then you're going to refer me to figure 1, which was the graph we made, and you're going to say your p is less than, 3.9 e to the negative 7. Your F statistic is 7.708. Whoops, that needs to be back over here. Sorry. And your degree of freedom is 141. Okay, so your report, the sentence in your report, in your discussion, is going to look like this. Okay, so, you've got your beautiful graph in your results section. Above that graph, you want to state your trends, right? And we talked about those trends here. Here we said that when we compared optimal to predation, generally predation yielded, maybe 10% more. When you had predators in general, you ate 10% more. However, when we focused across predators, you doubled the amount of calories compared to optimal. When you had 2 predators, you reduced it by, say, 4% or however many percents that is. And then you ate, half as much compared to optimal when you had 3 predators around. And so you're stating your trends. It was 3 times as much, it was 50% more, as you compare your optimal control to those other trials. You're referring me to the figure at the end of the sentence so I can go back to the image, to the graph, and see it. And then right after it, you're going to put that statement. You're going to say there was a statistical difference in mean calories per forager. My eye is going to draw to figure 1 to see the trend. And then I'm going to see, oh, look, there's a p-value. And the p-value shows it's significant. There's a significant difference. Oh, and there's an F statistic, so that means that they must have done an ANOVA. Okay, so you don't have to say ANOVA results show this, and you don't have to paste the ANOVA results. You guys can just write this sentence right here, okay? And that goes in your results section. I'm going to go over here. We're going to look at the mean calories per chip. If you guys are wondering where are these values coming from, remember our raw data? We have a column of total calories. We have a column of calories per chip. I just took the total calories, row A, column H, for trial 1. I scrolled down, I grabbed trial 2. I scrolled down, I grabbed trial 3, and I pasted them all right here. Okay, and we're just seeing if there's a statistical difference in the mean calories per forager across those trials. Okay. And then I did the same with the calories per chip. Grabbed all the calories per chips, so that last column in the table across all those trials, and we also can do an ANOVA to see if there's a statistical difference. So again, we go to the data analysis. We want to do a single factor ANOVA. We want to highlight all our data. Okay, so there's our input. Input looks good. We want to make sure the label's in the first row. We want our output range to go kind of in that spot. So we whoops, it just moved my selection here. Everything looks good. And we hit OK. And we go and we look. This is the area of interest. Oh, we have something to say here. Okay, p-value greater than 0.05, right? So how would we interpret that, you guys? No statistical difference, right? If it was less than 0.05, we have a statistical difference, okay? So no statistical difference in the mean calories per chip across those trials. And when we report it in the report, we would say something like, you know, there was no statistical difference in mean calories per chip across trials. Figure 2, P equals 0.3714, F equals 1.09, DF equals 141. Okay, and again, that sentence lets me know, because there's an F statistic, that you did an ANOVA, and it's telling me, because I'm seeing the p-value, that there isn't a statistical difference, but you've also stated that. Okay. This end thing, you know, is going to give us our results. So I basically just kind of made sure you guys had everything that you needed. But we just walked through it, and it's all there and available to you for you guys to check out. And so I can email this to you at the very end. But I wanted to make sure that we went through these calculations, that you understood why we did a chi-square. Again, that was to test whether or not we optimally foraged with a null hypothesis that said we foraged at random. Our observed chips equaled our expected chips. If we got a chi-square value that was less than that 5.991 cutoff, then we failed to reject the null, or we ultimately accepted the null that we foraged at random. If we had a value over that, we rejected the null. I think that happened in most cases. And we foraged optimally. You changed your behavior somehow. We then wanted to test whether or not our mean calories per forager and calories per chip varied across trials. So we ran an ANOVA using our stats package in Excel and determined based on the p-value if there was a statistical difference in those values as a function of those trials. And if we got a p-value that was less than 0.05, which we did in the case of mean calories per forager, then we can say, yes, there is a statistical difference in mean calories per forager as a function of those trials. And when we look at the graph that you're referring to, we totally see that it is very wildly different, you know, according to each trial that you guys experienced. But when we go down and we look at the mean calories per chip, you notice there's much less variation. And we were able to then test that using our data analysis package, again, using an ANOVA to test that. Now, one thing I wanted to show you also that I'm noticing here as we just scroll through, this one has the error bars, this one doesn't. Let me show you how you put those error bars on. You activate your data in the graph, if this ever happens to you at some other point. And you can use this plus sign. You can add error bars, okay? And you can click over here to the error bars and you can go to more options. We want to scroll down and we want to customize those. We want to pick a specific value, specify the value. And basically we want to go up to the data and we want to pick where the data is for this, okay? Whoops, let me move this over. The data that we need for that graph are right here, okay? So we're basically going to say, okay, in the positive error bar, so the one that goes above the bar, we got to click and pick where that is. Tell Excel where those data are. Click it again. Pick the same ones for the negative. So this would be going, you know, below the top of the bar. And now hit OK. And now when we go down, we've got error bars, and each one of them looks different. And that error that we see displayed is a function of each one of these being different, okay? So remember, if you ever are in a graph, it doesn't look like it has the error bars and you did standard deviation, you just activate that, hit your plus sign, go to your error bars, scoot over a little, go to your more options, scroll to your bottom, choose custom and specify your values, and then use these to go show Excel where the column where your data are that you need to graph the standard deviation. Okay? That was a lot of, you know, statistics and stuff, and I want to just, you know, kind of pull it all back together. Remember, you guys have 2 assignments. The first one you're turning in later today, and it has to do with introduction and methods. You should be, you know, fairly good to go with that. The part 2 has to do with results, discussion, and abstract, okay? And I'm going to pull up the rubric that I have up on Moodle. All right, let's skip over the abstract for a minute and jump down here to the results. Is there a narrative that describes the trends in each simulation? Okay, what we need in the results section are not only your 2 graphs and the table that has your chi-square value and your decision rule, but it also needs to have words above it, okay? It needs to have your trends. In the results section, you're not supposed to explain why it happened. Like, remember with the learning, you said it was because you guys were fatigued. That gets saved for the discussion section. The results section should just say we foraged, you know, and our yield was 5 times greater in predation than it was for optimal foraging. It was, you know, half as much in winter weather as compared to optimal foraging trial 1. Again, comparing the trends relative to one another, knowing that your control was the optimal, okay? At the end of each of those sentences where you're referring me back to that trend, to what the bars look like, you want to have in parentheses figure 1, okay? Draw my eye to that figure where you're showing me the trend. If you did a statistic on it, in this case, the ANOVA, after where you say figure 1, put the semicolon and say, you know, your P equals, your F equals, your degree of freedom equals, right? So those things in the table that we just noted. So above every graph, you should have a trends text that references the figure and can bring in a statistic, the F statistic, degree of freedom, and p-value from an ANOVA. You do that also for your calories per chip graph, right? You're gonna state your trend, refer me to the figure so my eyes can see the figure, and your calories per chip paragraph, that trend paragraph, might not be very long, right? It might be just that you state these were the ones that were the highest yielding and, you know, acted specialist strategy. These were the ones that were lowest yielding and maybe acting more generalist strategy. Refer me to figure 2, and then report back to me the F statistic, the p-value, and the degree of freedom to show me that you did a ANOVA to test that, okay? The table that you bring in, which again is right here, is your chi-square summary table, right? Where you've got your condition, your trial, your chi-square, grand chi-square, and the decision rule that you guys put forth. Just copy paste that into the Word document. You're going to have, you know, table 1 written above it with a title that says something like, you know, chi-square summary table. And you should state in all, you know, cases but one predator and all predators, we in all those cases besides those 2, we rejected the null in favor of the alternative hypothesis of optimal foraging. It was only in the case of one predator and all predators that we foraged at random as we found things on the landscape. And you can refer to us, you know, refer to table 1 at the end of the trend statement that you say there. So again, in the results, you need to have words. Those are trends text statements. You're not pulling explanations, but you're stating a trend, drawing my eye to the figure or the table, and each table and figure needs to have a caption or a figure legend around it, right? And bringing in an F statistic if you did an ANOVA on it. So that's what goes in the results section. In the discussion section, we want to jump to things like reminding the reader first of the goal. You know, it's always a good way to start it off. What was the goal of this experiment, right? That you were evaluating, you know, abiotic and biotic stressors on foraging, testing whether or not you foraged at random or optimally. And then you bring in what you found. You know, this is what we found for these particular trials, and then go and kind of explain in your mind why you think that happened, okay? And then also say whether or not it supported your original hypothesis. So if you're surprised, like we all might be, that predation yielded high calories, right? You can say that it was contrary to what we originally predicted in our hypothesis. And then you try and explain why you think this happened in your own words. And then you're bringing in articles. You're going to look at those articles that I have posted and kind of see if there's anybody else who found similar findings that can help support you in your findings. You put that in your own words, internally cite it like you did with your intro, and work from there. So, you know, I can imagine you're going to speak to each of those trials kind of chronologically, right? So you'll talk about your trends for competition and your trends for scavenging and learning. You'll speak about those trends later and speak about the earlier trials earlier, okay? So each result that you bring out and you're explaining in your own words, you're also going to say if it supported your original hypothesis, and then you're going to look to the literature to see if you can find anybody that found similar stuff to back you up in their research. You don't want to leave the discussion section without saying that there could have been sources of error, right? If anybody only counted one side of the chips, if the chips blended into the grass, if you were totally just done with it and tired and overheated, those could all be, you know, potential sources of error. If you could do it all over again, what would you do to change it? Would you create a new trial? Would you alter one of the trials, right? That's future directions. And then you want to end the discussion section with this significance. Like, why did you do this? Why was this important? What's happening in our world that might make it really important for us to know how animals forage, right? If we've got climate changing and there's less food available to them, if they're going to be colder more often, if they're going to overheat more often, why is it important for us to kind of get a good understanding about how animals forage and how they can forage better and more optimally? Okay, so that's kind of the big take-home message at the very end, the why we did this. And usually we write it in this order. You know, we start off with the results, which we've kind of worked through together. Then we move into the discussion section, and it's only at the very end when you go back and you write your abstract, right? The abstract is just a quick summary, 250 words or less, a take-home message of each of your sections, right? So you start off and broadly have a sentence about optimal foraging in animals. You might have another sentence that says we tried, you know, a trial simulation using poker chips on the landscape, foraging under this, and this trials, okay? Then you have a sentence or two summarizing some of the really important findings from your results, and then a sentence or two kind of describing how you explained that, and then finally you usually end off with the take-home message, that overall significance statement at the very end, okay? So the goal for you guys for next week, I'm going to send you this data set, and you can kind of cross-check it. I'll post this video so that you can refer back to it. Will be for you to kind of work up the rough draft, abstract discussion, and results, okay? And that way you'll have a whole rough draft complete. You'll await feedback from me and should be good to go on a revision later on in the semester. Any questions? We went through a lot. We had a lot of stats and stuff, but hopefully, I mean, one of the goals is for you guys to gain more confidence with Excel, to understand statistics a little bit better and why we choose to do these sorts of stats, and then to kind of just enhance your science writing, okay? So hopefully this lab has sort of gotten you started along that path. Any questions?
Yeah, I have a few questions.
Okay.
So I had already finished like the rough draft for the methods and the introduction, and I submitted it.
Mm-hmm.
I didn't include like the graphs and stuff for the methods section.
Oh no, you don't put the graphs in the methods.
Okay.
Graphs go in the results.
Oh, so I just like had put, I think there was like a brief like couple lines that was in the lab handout or something, and I just like wrote like 3 lines in the after for my data analysis. That's it. So
oh, I see what you mean. Is this Edgeman that's speaking?
yes.
Okay, yeah. So the data analysis subsection on the methods was meant for you to just say, we're going to graph mean calories per forager, we're going to graph mean calories per chip, we're going to run an ANOVA on both of those to see if there's a statistical difference in them across the trials, and we're going to run a chi-square analysis to see if we're foraging at random versus foraging optimally. This is what my null hypothesis is. This is how I calculate my expecteds. That sort of thing. So it's just broadly like this is how I'm going to approach it, but your actual results, the graphs that we just made, go in the results section, right? So over here in the results section, you want to have a narrative describing the trends, like I mentioned. You want to have reference to the statistical tests at the end of those sentences. So draw my eye to figure 1 or to figure 2 and then report your F statistic, p-value, and so on. Each of those tables or figures are going to have a figure legend or caption, just like the header above on a table and the kind of right below the figure legend, which is a title on your figures. And then again, you want to bring the graphs and the tables in on those. So really, you know, the meat of your paper comes when you jump to the results. The intro is more of like, I'm gonna tell mom and dad, I'm gonna set the stage, I'm gonna like give everybody the background information. The methods gives you kind of, okay, now I'm gonna pretend like I'm sitting there watching this happen. Gives you kind of the context so that you can better understand the results. The results will give you the actual visuals of it in graph and table form with a quick interpretation in words above it. And your discussions where you put it all together. It's where you interpret it, it's where you get a chance to explain why you know, winter weather was so much worse than optimal, and why the two types of competition versus optimal look like they do, right? Because you guys were physically there on the landscape, you can kind of think about how you behaved, and then you might actually find an article that shows, oh, I saw in gray foxes and red foxes that they reduced competition by eating different things, right? One of them eats more plants, the other one eats more animals, and that's how they were able to reduce competition so that they can gain more energy when they're both acting at the same, you know, and active at the same times. So if you can find good articles that kind of speak to that, how, you know, organisms can change their behavior when experiencing some of these same threats, definitely bring them in and, you know, paraphrase them and internally cite them. And it's totally okay, you guys. You don't have to just pretend like you're a squirrel. You could pretend, you know, you can draw from articles that talk about birds, that talk about deer, that talk about, you know, foxes and moose and coyotes and stuff. If you can find really good examples across a whole bunch of different animals, I mean, remember, we're all animals, right? And everybody's goal is to like gain as much energy so we can grow, survive, grow, and make babies, and not die, right? And we want to do that as efficiently as possible. That's kind of the evolutionary strategy that animals tend to have. Good question, Edgemon. Anything else?
And yeah, okay, thank you for answering.
Sure.
And also, when are you gonna email this to us? Or, well, actually the video is actually helpful, so sorry about the video.
Yeah. So the way the video works is as soon as I finish up here and stop it, it's going to take maybe 40 minutes to resolve into an MP4 video, and then I will bring that into YouTube so it'll have closed captioning in case anybody in our class has special considerations. And as soon as it finishes up on YouTube, I'll post it on our Moodle site, and I can actually even send it to you guys in an email too. And I will simultaneously attach this Excel sheet to you.
Thank you so much.
Yeah, of course. And I'll also I'll post them all inside our, you know, our Moodle area. So you'd have access to them too. Anybody else with questions? Thank you for hanging on. I know it's kind of boring when we're not physically all at the computer doing this kind of stuff, but you do now have an opportunity, you know, to try this on your own, to flip back in the one that we worked on and look at the formula again to refresh your memory how we did that and why we did that. But I think we did enough of them for you guys to kind of get the gist, right? I think I've lost everybody. Are we all good?
Yeah.
Okay. All right. Well, as you move forward with this, if you guys are finding that you need me, just reach out, okay?
Okay.
All right. Good luck with stuff. And I'll send you an email as soon as all this stuff posts.
Thank you.
You're welcome.
Thank
I will
you.
see you. Yep, I'll see you next week. And next week, I believe we're face to face. So I'll send an email reminder to everybody.
All right.
Okay. See ya.
Yay.
Danielle, I have a question.
Sure.
I just didn't want to ask you because it's kind of I'm just having trouble with like the methods section. So is there like
Yeah.
a spot spot I can look to help me write that?
Yeah,
part?
why don't we jump right off? This is Brendan, right?
Yeah.
Why don't we jump right off and we'll do a little personal one-on-one Zoom, okay?
Okay.
All right, I'll send you a link to a Zoom in a sec.
Okay, I was having Wi-Fi problems at the end there. It just kept kicking me off and it kept freezing, but
Oh, do you want to just call my office? It's 40564.
we could try the Zoom. It should be okay now.
Okay.
Okay.
All right, I'll give you a Zoom link in a sec.
All right, thank you.
Yep. Bye-bye.
Bye.